And now let's take a look at transformation of exponential functions. Now there really isn't a parent function for an exponential. You'd have your a times b. You could have a horizontal shift. You're gonna see that up in your exponent. It's always going to be next to the x. And then just like we've seen in all the other function families, you've got some value hanging around on the outside, that k value, that's going to be your vertical shift. Usually the higher your a value is, greater than 1, the more vertically stretched the graph is going to be. If you're negative, if you have a negative in front of your function, just like with any other function family, it's a reflection over the x-axis. And your horizontal shifts, if it's at x minus h in the exponent position, you're going right h units, plus h, you'd be going left h units. Don't forget, I know my students always get confused on this. If your h value, if you're moving left, your h value would be negative. So if you could imagine, if you were to put in a negative value for h, you get x minus a negative number. A negative equals a positive. Therefore, it appears as an x plus h. So you kind of got to almost think a little backwards when you see it. And again, if you have a negative, this is up here, and in Algebra 2 high school, you really aren't going to see this too much. It is in your try it, so I thought I'd go ahead and show it to you. So if you have a negative in front of the x in your exponent, you're going to be reflected over the y-axis. Vertical shifts, just as they appear, it's going up k units. If it's positive, if it's minus, it's going down however many units. So let's take a look at these. We're going to kind of go through these, your A, B values. We'll talk about y-intercepts, and we'll pop Desmos up on the screen and take a closer look at these. So on A, now remember your B value is what that exponent is attached to. So your B value is 3. That means your A value is -1. Your B is 3. Now, my y-intercept here is going to be at 0, -1, because there's my A value. I've got a reflection going on here. That negative here in front of the 3, that means we are reflected over the x-axis. Now, if you can imagine, you know, what we did in the last video in our first lesson, example 1, if you would have just had, our example was 2 raised to the x power. Well, 3 raised to the x power isn't going to be that much different. We had an asymptote at y equals 0. Well, if I have just flipped my graph over that x-axis, excuse me, my asymptote is not going to change. It's still going to remain at y equals 0. So now let's take a look at B. H of x equals 3 raised to the power of x minus 4. So again, my A value is 1. My B value is 3. And I have a k value here of -4, which means I am moving my graph down 4. And now we don't have a parent function, so really you'd be looking at your b value raised to the power of x. That kind of almost acts like your parent function. So now some key features. Well, I have moved my graph down 4. So that means my y-intercept is going to change. And remember, your y-intercept is where the x value is 0 because you're on the y-axis. So if I compute this algebraically, x has to be 0. So let's see what the corresponding y value is. So I've got 3 to the 0 power minus 4. 3 to the 0 power is 1. 1 minus 4 is -3. So I've got a y-intercept here at 0, -3. My asymptote is also going to change because remember, I started out with an asymptote at y equals 0, And if I've moved my graph down 4 from y equals 0, well, that means my asymptote has also moved. So that means my asymptote is now at y equals -4. And these triads. So here g of x equals 5 raised to the power of x plus 3. My a value again is 1. And my b value is 5. I have right here, it says plus 3. That means I'm going left 3 because my h value would have to be -3. Now your y-intercept, because remember, I would have started out, if I just had 5 raised to the power of x, my y-intercept would be at 1, my a value is 1. But I have picked up the graph and I've moved it left 3 units. So it's no longer going to be at 1. So let's see where it will be. I'm going to take 5 raised to the 0 power plus 3. 0 plus 3 is just 3, so I've got 5 to the power of 3. So that's at 125. So I have a y-intercept at the ordered pair 0, 125. Now your asymptote. So my asymptote started out at y equals 0, and I just moved the graph to the left. If I've only moved my graph to the left, I haven't done any kind of vertical movement that would change the asymptote. So my asymptote here is still at y equals 0. And now here on this h of x equals 5 raised to the negative x power. So this negative right here, that reflects the graph over the y-axis. And again, I don't want you to be too concerned about it. I don't think it's a bad idea for you to see it. My a value is 1. My b value is 5. Now, just because I am reflecting over the y-axis, my y-intercept is not going to change. It's still going to be at 0, 1. And my asymptote, because again, I'm not moving my graph vertically. That asymptote is on y equals 0. Remember, y is a vertical indicator. It's not moving up or down. So therefore, my y-asymptote is still going to be at y equals 0. Now let's go ahead, let's pull up Desmos, and let's take a look at what some of this looks like. And I encourage you to play around on Desmos to get familiar with how these graphs will look. So we started out with 3 raised to the power of x. Y-intercept of 0, 1. I have an asymptote at y equals 0. And now let's reflect it over the x-axis. So I'd have a -3 raised to the x. And so now we calculated it algebraically. Here it is graphically. My y-intercept now changed to 0, -1. Notice my asymptote stayed the same, y equals 0. Now my end behavior has changed. As x approaches positive infinity, now my y values are approaching negative infinity. Let's take a look at what happens if I do a vertical shift like we did in our try it. Let's go, we did a -4. So there it is. Here's my new y-intercept, 0, -3. Notice -3 is 4 units away from 1. And my my asymptote has now moved down to y equals -4. Now let's take a look. We had 5 raised to the power of x. And again, still we have a different b value. Y-intercept is still the same. And now let's shift this guy 3 units left. So that is going to be 5 raised to the x plus. Nope, missed it. To the parenthesis x. And there it is. It has moved 3 units. My y-intercept, this is the one that had a y-intercept of 125. I'm not going to scroll all the way up there, but it is there. So my y-intercept changed. And again, it is just moved 3 units to the left. My asymptote has not changed. Let's make this a negative x. And there's a reflection over the y-axis. I still have a y-intercept of 0, 1. And I still have an asymptote of y equals 0.